Okay, so a couple of quick announcements before we dive into the math. First, welcome back. I hope we had a wonderful spring break. With apologies, I did not intend to give you a quiz as a welcome back from spring break. I didn't plan on having I guess I planned everything for the semester, but I didn't intentionally put a quiz on the day back after spring break, but that's where it happened to be. Today, we just had our 5th quiz, which means we're at the halfway point in terms of our 10 quizzes. And we're going to review a little bit about transformations and then talk some more about sinusoidal functions. Next class, we talk some more about tangent and the other, turns out there's a total of 6 trig functions. We have seen 3 of them. We focused on sine and cosine. We've mentioned tangent, but we'll give tangent a little more attention next time. And then there's these other 3 trig functions that we'll spend a little time on next class. And then you can see the next topic is inverse trig functions. And I put 3 days for inverse trig functions. That should give you a sense of how important that topic is to us. And then we have a review day for a test and then the test. So the test is still kind of far away. Anyway, it's coming April the 2nd. Between here and April the 2nd, there's an important day, not necessarily for this math class, but March the 27th, what's happening at GCC? It's advising day, which means it's the first day that you will be allowed to register for classes for the fall semester. I know it seems very early to think about the fall semester, but this is when registration starts. And GCC is piloting a new program this semester, and I just want to point it out to you. If you go to our homepage, on the main page, you will see some announcements. So let's scroll down a little bit here. And Open Classroom Week. Have you guys heard of this? Has anybody heard of Open Classroom Week? That's okay, it's a new thing. You click on it and it gives you a description of what's going to happen. The week of March the 26th, which is the week that Advising Day happens. Advising Day is on that Thursday. Starting on that Monday, a lot of classes are going to be open for you to sit in on to try to help you decide what courses you might want to take in the fall. So you can like look at this list of courses that might be available, and you can say, okay, am I interested in taking an accounting course? Let me sit in on an accounting course during that week. Or am I interested in taking a course with this guy right here, Jeff Galbraith? You know, like does his style, you know, like do I think it's going to work for me? Well, this is a great opportunity to answer that question, right? For the first time here at GCC, you'll be able to sit in on classes. So pick classes or pick teachers or pick both. This is a list of, it says a list of possible open classes. I think this is just a list of every class. Outside the classroom doors all around campus, there's going to be a little sign that says either open or closed. And every teacher that walks into their class that week is either going to turn it to open or turn it to closed. And then you can just have a plan, and you might end up wanting to take some classes that are closed, but I suspect that a lot of them will be open. Any questions on this? Okay, so that's coming up. That's all of next week. Advising Day is Thursday of next week. All right, so on page 28, we'll start at the top with number 1. We go to Chris B. Today we talk.
About horizontal shifts.
Okay, thank you. We've talked about a bunch of different transformations. We've done vertical stretches and shrinks. We've done horizontal stretches and shrinks. We've moved graphs vertically, up and down. We have yet to move graphs horizontally, at least this semester. We'll go to Vance for number 2. So thinking about like on the previous page, when I say starting point, that's kind of a misnomer because these graphs go forever left and right. But for me, the starting point is where the graph hits the y-axis. So I'm just focusing on the spot where the graph hits the y-axis. And if your choices are top, middle, or bottom, where does that graph hit the y-axis? That's at the top. Where does that graph hit the y-axis? That's at the middle. And if I scroll down to this guy here, where does this one hit the y-axis? bottom. And if you look at every graph we've examined so far, the graph has hit the y-axis at one of those three spots, top, middle, or bottom. But, you know, a lot of times life isn't as nice. It doesn't happen to start perfectly at the top, middle, or bottom when t equals 0. So we're going to relax that for today. We'll go to Richard for 3. Okay, x minus 5. Can you guys point which way is that one relative to the original x squared graph? So lots of pointing, lots of pointing. So that x minus 5 goes to the right. Yes, it's inside the parentheses, so it's a horizontal thing. That minus 5 means move to the right 5. Anything inside the parentheses does the opposite of what I expect it to do. That's how I remember it. And that plus 3, can we point? What does x plus 3 do? That's going to shift left 3. Okay, so that's what it looks like for a very familiar graph, the x squared graph. Now let's see what it looks like for a new graph for us, the sine graph. We'll go to number 4. Kate. Okay, so the first one is y equals sine of t minus pi over 4. Forget the minus pi over 4 for just a second. And can you guys graph sine of t by first plotting the 5 important points? Can you plot 5 points on that graph and connect them so that we see sine of t? And if you're not sure what I mean by the 5 special points, ask a neighbor. Okay, so let's come on back together. So that's my original sine of t. Starts where? Top, middle, or bottom? Starts in the middle, and it's on its way up. So we plot our 5 special points. It is part of your job to either know or know soon where those 5 points are. It ends at 2 pi. Halfway in the middle is pi. Halfway again is the top. So that's a pi over 2 at the top and a 3 pi over 2 at the bottom. So it's our job to know what those points are either now or very soon from now. Okay, so now let's deal with this minus pi over 4. Can you guys point? Where's the graph going to move with that minus pi over 4 in the parentheses? I see a few pointers. I want to see more pointers. T minus pi over 4. That goes to the right, pi over 4. Next question, where exactly is pi over 4 in this graph? All right, let's label a few things here. This is pi over 2, that's the halfway. Where's pi over 4? It's half again. So that's quite fortunate that all of these boxes are exactly pi over 4. Okay, it's supposed to move to the right by pi over 4. Where does this point move to? Pi over 4 to the right, which is exactly where the first thing is. And then the top point moves pi over 4 to the right. And so I would encourage you guys to plot 5 new points. Each of them moved pi over 4 to the right. How are we doing? It's okay?
Yes. Moving over.
Yeah. Any questions on that one? Horizontal shift, pi over 4 to the right. Okay, let's come back to the second one in just a second, but I'll go ahead and project the answers to the quiz, or at least my current version of the answers, and then you can find errors for me again. 8/7. All right, and then we'll move down to the next one, up there at the top. 8 over 7 times 180 over pi. You don't have to do any arithmetic. You don't need to do long division. You just leave it in the place where you can.
Why would you ever do 1440 over 7 pi?
I don't know, just in case some people did that. All right, that's fine. And then the bottom one here, I bet I got a lot of you guys on this bottom one here. Aha, I did get a lot of you. All right, so first, I almost got me. Which one is the x? X is cosine. All right, so I just started writing sine. That was poor. But what did you guys forget? 7. You swapped them. Yeah, so it's real easy to forget because we've been saying for weeks x is the cosine, but that's when we're dealing with which special circle? The unit circle, the circle with a radius of 1. If it's bigger than 1, you got to account for it here. All right, that's only a -1 on that one. Okay, we've got amplitude is 3, equation of the midline is y equals 10, and then, oh, I'm sorry, the period was 3, the amplitude is 15. And then as far as the equation goes, that's what mine looked like. How did I know this was a cosine graph looking at the, yeah, it starts right up there at the top. Okay, cosine. Okay. All right, so let's go to 4b. So I still can't tell if you guys like me to do this or not, because like people start kicking themselves during class. Yeah, I don't know. Maybe we'll tell people just like close your eyes for 30 seconds if you don't want to see the answers. Okay, let's take a look at part B. Sine of 2t minus pi over 2. Okay, there's two things happening in the parentheses. The first thing happening is this 2t. That 2, is it a horizontal or a vertical thing? Horizontal. It's in the parentheses. And we know it's either going to be stretching or compressing. And it's a times 2. Can you guys tell? It actually compresses. Again, it's opposite of what I think. I think if you're doubling the t, you should be stretching the t's, but it's actually the opposite. So this is going to be a horizontal compression. Everybody's going to get twice as close to the y-axis. And then there's this minus pi over 2. Can you guys point again? Which way is that one shifting? Minus pi over 2 inside the parentheses is to the right. Do you guys see? Cassidy, do you have a question? Yeah, so we've got two different things happening here, and we want to know if it makes a difference what order we do them. Can you guys imagine? You take your sine graph, your original graph that's black up here in the top right. You smush it horizontally by a factor of 2, and then you walk it to the right, pi over 2. You land somewhere. Now think instead, start with the original one again. Now shift it pi over 2, and now smush it horizontally. Now I'm standing here, and I would really like to do this. But that's not what the smush horizontally is. It's not around here anymore. It's always smushed with respect to the y-axis, which is still sitting over there somewhere to the left. Do you guys see that we're going to get different things? It's just not going to be the same graph. And this is troubling. The order in which we apply these things will give us two different things. We get two different graphs depending on whether you smush first and then walk it to the right, or walk it to the right first and then smush. It's going to be different. And we got to figure out which one it is. And this is exactly what today's question is about. In terms of the order of operations, I think it's really, really easy to miss this. What would you do first if I just gave you like a t value and I said evaluate this thing? Would you times 2 first, or would you subtract pi over 2 first? You times it by 2 first. So in theory, like horizontal smush and then move to the right, because you're timesing it by 2 first, and then you're subtracting pi over 2. And I say in theory because that's not the right answer. It's really, really unfortunate that the way to think about this one is to first move to the right by pi over 2, and then, and only then, horizontally compress.
I thought you always did your stretches.
Yeah. Well, I'm saying that somewhere along the line, somebody has lied to you. And yeah, it could have been me. I could have lied. I don't know. It's a line that we tell because the truth is quite complicated. It is very counterintuitive what the truth is. This is the truth. So here's what we do instead. I'm not going to lie to you anymore, but I am going to do what Tacite suggested, because this is not what I want to do. This is quite counterintuitive. Okay, so it's the truth, but I'm crossing it off. Instead, factor out the 2. I'm going to call it the b. B is the number we've been, or the thing we've been saying is in front of the t. Factor out the 2. Okay, so let's do that. Factor out the 2. So we get y equals sine of, all right, there's a 2, and then there's parentheses. And then this is the part that's also confusing, because we're trying to factor out a 2 from something that doesn't have a 2 that goes into it, right? Yeah. How do you factor out? What are you really doing when you're factoring out? The choices are addition, subtraction, multiplication, and division. When you're factoring out a 2, what are you really doing? You're dividing by 2. You're sticking the 2 on the outside, and you're dividing everything in there by 2. If you divide this guy, if you divide this guy by 2, what do you get? You get 1t, which is why there's a single t sitting in the parentheses. Well, then we better divide this guy by 2. That's what we're doing when we're factoring. If you divide that by 2, what do we get? We get pi over 4. Factoring is really dividing. Okay. Now again, I have two things. I have a horizontal compression still. I have a shift to the right still. But how much is the actual shift to the right? How far are we going to the right? It's actually pi fourths. So I'm going to do this in the order that I want to do it in, which is to step 1, horizontally compress. No, the one in red is right, but it's very counterintuitive. It is not how I think of my shifts. You can do it either way. So here's the idea. I'm going to finish what I'm writing here, and then we'll go shift to the right by pi over 4. If you do red or if you do purple, you will land on exactly the same graph. So either way is fine by me. You're going to get the right answer either way. But to me, I like Tassaday's suggestion. I like doing my horizontal shift at the end. I like getting my basic graph by like compressing. Compressing is a difficult thing to do, right? I mean, it's just not, it's a lot easier for us to shift right, left, up, down than it is to compress and stretch. So I would like to get my compressing and stretching done early before the graph has become unrecognizable to me. And then I can just shift it, and that's easy. So how do I want you to do it? Either way. But every time I do it, I'm doing purple.
So why would you allow me?
You'd have to talk to her about that. My guess is that you never encountered a horizontal shift and a horizontal compression in the same equation. Maybe take a look. Was it factored out?
Yeah, no, I don't think on the final pass.
Was it like did it look like this first guy, or was the number factored out in the front?
It might have been factored out.
So then, if it's factored out for you, then the truth is what she had said. I don't know. Yes, purple way is for the factored version, which is how I'm going to do it every time.
So
All right.
Just factor.
I think that's the safest thing. Yeah. Okay, so let's put it all together. Actually, once we figured out what to do, it's not hard to do it. Okay, we are horizontally compressing. We're smushing by a factor of 2, which means everybody gets twice as close to the y-axis, or half as far away. So then let's go back to the black curve at the top here. It used to be the top was at pi over 2. Where is the new top when you smush it? It used to be at pi over 2. And it becomes to pi over 4. Yeah, everybody, that black graph gets smushed in. Everybody happens twice as fast. And so I'm just going to put one new dot up here at pi over 4, which is there. And that's the top. The middle is the next one, then the bottom, then back to the middle. So this is the graph of y equals sine of 2t. I'll give you an alternative. If this idea of smushing, like so that it's half as close to the, or twice as close, I don't know how to say it, to the y-axis, with sine and cosine graphs, you could also just think of the period. The formula for the period is 2 pi divided by b, where b is the number touching the t. It's the b in this case. It's 2. So 2 pi divided by 2, which is pi. So if I just said draw the sine graph but make the period pi, I think you'd have no problem finding the 4 points. So either way, like use the period formula or like literally smush things down to half what they were. And then once we've done that, we're going to take the whole thing and shift it to the right. By how much? By pi over 4. And we said pi over 4 was actually one box. So we're just shifting each of those guys to the right by one box. So everybody moves one to the right from what they were. And this is the graph of our answer. Sine 2 t minus pi over 4. Not so easy, huh? There's a reason we leave the horizontal shifts until the end. Okay, we're going to do 2 more of these. Let's see if we can kind of clear up any murkiness that's happening here. First, we'll go to number 5. Tacita, did you read? No, go ahead. Okay, so the phase shift of this graph was how much? Was pi over 4. That is how much it shifted. It's very tempting to look at this and say it's a pi over 2, but it is not really a pi over 2. It was really a pi over 4 in disguise. So that's my definition of phase shift. I think your book's definition would actually be this pi over 2, but I like to think of it in the way that we've done over there in purple. All right, we'll go to the next page. Emily? Okay, Steve, number 6. Okay, so everything getting pushed together for this guy. Now let's figure out all the different pieces. We've got an amplitude. Can you guys hold up how many fingers? What is the amplitude for this graph? The amplitude here is 5. It's the number sitting in front of the sine function. And then we've also got a midline. Okay, ignoring any negative numbers, what is the midline? Is it y equals -2? So y equals -2. And then we've also got a period. You have to do a little bit of work. So see if you can use the same kind of equation that we did before. We said that the period was 2 pi over b. If you do a tiny bit of work, you get that b is always 2 pi over the period. Oh, I suppose that isn't the version we need for right now. We'll come back to that one. The period is what we're after. We need 2 pi divided by b, 2 pi divided by the number in front of the x. 2 pi divided by pi is 2. So the period here is 2. Okay, and then there's one more thing, the new thing for today, and that's the phase shift. So first, can you guys point? Are we going left or right? That +1 says we go left. And the phase shift for me is how far we are going. And how far are we going? We are going 1 left. So I'm going to say 1 left. Or if you wanted to say -1 is the phase shift to indicate left. Left 1. Is it really 1? Or do we have to do something funny? It's already factored. So we don't have to do anything funny. If it's already factored, you can see the pi in the front, and then there's just an x plus. Then that +1 is really a pure left 1 movement, as opposed to part B where it's not factored. So that's what we're going to do first in part B. Okay, so let's see if we can come up with the graph of this thing. We're going to put all these pieces together. One thing I like to do you guys remember what I like to do with the period once I've figured it out? Always divide it by a certain number. Always divide it by 4. For my 4 quadrants, for my 4 pieces. So the period divided by 4, always 4, is 2/4 or 1/2. Okay, so let's see if we can start throwing some things over onto the graph. All right, the midline is where I'll begin. Y equals -2. We got 1, 2. And then I'd like to figure out the top and bottom of my graph. Where's the top of my graph? Can you hold up the number of fingers if you can find it? There is the top of the graph. The middle is at -2. One of those numbers tells you how far up you have to stretch. It says up 5, so you go up to 3. So let's see, that's 2, 1, 2, 3. That is the top of my graph. I'll put another dotted line to kind of, I'm starting to trap where this thing lives. And then down below, I'll put my third dotted line. This thing is trapped on the bottom by a certain y value. What number is down there? That's a -7. Okay, up 5 and down 5 from the middle. Okay, there's nothing else to do in terms of the y stuff, but now we think about the x stuff. I'm going to come up with my starting value for t. Normally my starting value for, sorry, I guess we're using x here. My starting x is always 0. I just think about the y-axis as being the start. But that's not the start for this one, because we shifted which way? We ended up shifting to the left by 1 unit. So instead of starting at 0, I'm going to shift left 1 unit. I'm going to start myself at -1. So I'll do all the x stuff in green. So -1 is my start. I'm not going to be, are we on a pi scale? Yeah, we might, like if we're on a pi scale, then yeah, it could get tricky. But yeah, the period here is 2. So it turns out that's kind of a nice number. And the period divided by 4 was a half. Okay, so then every important point is happening every half. Given that, let me stretch this a little bit and say -1 is out there. I want to have enough space so that I can see what's going on. And then I'm just going to step to the right by a half every time. That's my quarter period. So we step to the right by a half. We step to the right by a half. That lands me at 0. Another half. And then finally, one more half lands me at 1. And those 5 green marks are going to correspond to my 5 special points. It always comes back for me to the 5 special points. Can you tell me something that you like about the starting at -1 and ending at +1? That's a 2. Why is that a good thing? That's the period. So the full graph, full cycle is going to be in there. Okay, last piece of the puzzle. Thinking about where this guy starts. The choices are top, middle, and bottom. This is a sine graph. Where does it start? It starts in the middle. So the middle for me is this purple dotted line. It starts at the far left at -1. That's my first dot. Can you guys plot the other 4 special dots and then connect? Okay, so we plot our 5 special points, connect the dots. We know sine starts in the middle and goes up, so that's all that I need in order to find the special points. Any questions on that? So full on graphing like a sinusoidal function with all the different transformations possible, it's a process. But I'm hoping that by breaking it up, that these pieces are manageable. And one thing I like to do is check my work on the calculator. So let's have a look. I have typed in the original function, careful with the parentheses. And then I typed in the window so that it matches perfectly with what we've got here. We said -1 to 1. The top is 3, the bottom is -7. I've typed those numbers in. I even did something, this is Ali gave us this idea the other day. Why did I put a 0.5 for the x scale? That's our quarter periods. And so the dots should line up perfectly. Oh, one small thing. I guess I should have made sure I was in the right mode. What mode should I have been in? Radian, because we're doing everything with pi's here. And you can see like that's exactly what it should be. It's exactly what we drew. It started at the far left in the middle. It went up to the top, hit the top, came back to the middle, bottom, and then the far right. Any questions on that? Okay, and let's take a look at part B. And in part B, I want to make a slight change. Can you guys cross off both the pi's in part B? And so the first fraction, I want it to be a quarter instead of pi over 4, just make it 1 over 4. And the second fraction, you can leave it, just cross off the pi, so it should be minus 3/4. Everybody have the updated one? And you might think that getting rid of pi's would make life better, right? But it's actually going to make it worse for the reason that Topher had mentioned before. What was the period for the example we just did? The period was 2, which is quite a nice number. The period formula is a 2 pi divided by b. The only way that's going to be a nice number is if b has what in it? You need b to have a pi in it if you're going to cross off the pi's. So actually having pi's there makes it nice. Now we're going to have to deal with Topher's issue where like we've got a pi scale going on. So let's cross them off and see if we can deal with this. First thing I want to do is factor it. Can you guys factor something out of both of those? Check with your neighbors, see what to factor out, and find out what's in the parentheses. So we factored out a quarter. Any problems getting x minus 3 in there? Okay, with your neighbors, can you guys run through the same vocabulary game that we played up here? All this stuff in blue. Let's find 4 or 5 different numbers. Okay, so I think a bunch of groups have got our numbers. Amplitude was 2, midline was at y equals 6, period was 8 pi, and then the phase shift was 3 to the right. It's real tempting to look at that original thing and say it's going to be 3/4 to the right, but it's not the way we're doing it. So it's shifting 3 to the right, and I always like to take the period and cut it into 4 pieces, and I get 8 pi over 4, which is 2 pi. So let's see if we can graph this thing. So we'll go ahead and start with our axes. And then I'm going to again trap it, top and bottom. First I'll find my middle. Where's the middle? There's a y equals 6. So I'll put y equals 6 up here. And then how much up and how much down are we going? We're going 2 up and 2 down. I already don't like my graph. Why not? Yeah, I'm going to have issues if I try to draw this thing to scale because 2 up and 2 down means the entire graph is going to live inside of there. And that's not so great. So attempt number 2. Maybe we will erase this horizontal line and just move it down a little bit. Okay, and now we try again. How much up and how much down are we going from the middle? We're going 2 up and down. That's the amplitude. So if I go down 2, I land at 4. If I go up 2, I land at 8. Okay, let's think about my x's now. Normally, I want to think about my x equals 0 as my starting point, but everybody's been shifted which way? To the right by how far? 3. So instead of starting at x equals 0, I'm going to start at x equals 3. So let's try that here. So x equals 3 stays that one. And then my period over 4. Period divided by 4 is 2 pi. Now you can see the issue that Topher was talking about before. And there's no way around it, is that I'm starting at 3, but I'm going over by 2 pi's.
3 is really close to pi.
The 3 is close to pi, so it should be not too far from nice. Okay, so like I'm not super concerned with scale at this point. We just want to get a rough sense of what this thing looks like. The graphing calculator will do better than us no matter how much we practice, but at least we want to know where to look. Okay, so if it starts at 3, and I'm going over by 2 pi's every time, what's the next point? Exactly, what is the next point? It's 3 plus 2 pi. That's just what it is. Going over by 2 pi. And then what's the next one after that? You're going another 2 pi. 3 plus 4 pi. And then do 2 more. I want 5 special points.
It gotta be a lot less ugly to compare to 3 to a ratio.
Make 3 with something with pi's in it?
Yeah.
What do you mean?
Like 9.5 pies.
Oh, I see. I see. And then you could get 2.95 pi. Yeah, yeah. Why do I like the 3 plus 8 pi? That's the period, right? If we start at 3 and you end at 3 plus 8 pi, you have traversed 8 pi altogether, and that's what we expected. Okay, plot 5 special points and connect the dots. Think about the fact that this is a cosine. It does not start in the middle. So find the right starting point and plot 5 special dots. All right, where does cosine start? Cosine starts at the top. And so we just have to find the top and our first point right there. And then we get to the middle, and then we get to the bottom, and then we get to the middle again, and then finally back up to the top. Questions on that? Okay, and again, if you wanted to check it on your graphing calculator, just type in exactly the window that you see, and you should see 1 complete cycle of cosine. Okay, let's take a look at, well, before we take a look at 7, one thing I want to say, I guess I wish I would have put this in the notes, but I'll put it here. I'm going to draw 4 real quick graphs: sine, cosine, minus cosine. Sine, negative sine, cosine, and negative cosine. And you might not need to copy any of this if you just want to wait for kind of the punchline. Okay, so here's the punchline, and then you can decide what, if anything, you feel like writing down. If you have a graph that starts in the middle and it's on its way up, then it is most naturally a sine graph. If, however, it starts in the middle and it's on its way down, it is naturally a negative sine graph, just flipped over. So that's 2 possibilities. You could start in the middle going up, or start in the middle going down. Or you could start at the top. If you start at the top, there's no choice but to go down. And if you're starting at the top, you are a cosine. If you were a negative cosine, then you would have just flipped over and you would have started at the bottom. And so you're going to find one of these 4 possibilities for every trig modeling thing I give you. You just have to look at where a natural starting place is and then pick one of the 4 choices. You're either going to pick sine or negative sine or cosine or negative cosine. Like on the quiz today, you guys made a choice. Maybe we made a bad choice, I don't know. So where does this guy start? Starts at the top. So what is it? It's cosine. That's the choice. Okay, it's an easy choice once you know what the 4 possibilities are. So okay, so let's see if we can use that in answer number 7. We'll go to Todd. Okay, let's pause right there. That's a lot of information already. So ultimately, we're looking for a function, some equation that will model this, but I think it's a whole lot easier to take that information and make a picture before we make the equation. So let's start with the picture. Okay, so the first thing that Todd gave us that we can draw was that low tide is 40 feet. Whoops. Low tide is 40 feet, and it happens at 2 a.m. There's 2 a.m. There's 40 feet. And then there's a 20-foot difference between the tides. So how high is this thing getting? Getting up to 60. Is that the amplitude? 20? Not. Right? That's not the amplitude. Okay. And it says it takes 12 hours. So if it was 2 a.m. to get to low tide, when do we get to high tide? 2 p.m. Okay, 2 p.m. doesn't belong out there. What belongs out there? 14. That's what belongs out there, right? AM and PM, they're not good. I don't know if military time is good, but it's better than AM and PM. Certainly in terms of math. You don't want to put another 2 on the x-axis. So at 14, what's the tide? What's the height? 14 is when we're up there at 16. And that's all that we need. So can you guys come out here to the right and plot another point? You need to know the x value and the y value. So that happens another 12 hours away. That's at 26. And what's the height? Now we're back to 40. Okay, I like to have 5 points. That's only 3, but you could probably like fill in the blanks, right? Like we know what this thing looks like. Starts at low tide, goes up, comes back down, and then is ready to repeat. So that's what the height of the water does. Okay, just for kicks, we don't need to do it for this problem, but can you guys find the coordinates? Oh, I always like my 5 points. Can you find the coordinates of the 2 that we're missing? So what's the horizontal middle here? Is it 50? And then what's that's an 8. And then the other one here is 20. You can do all of that by just averaging, just finding pairs of numbers and averaging them. Or think about the period. What is the period here? Is 24, going from low tide to low tide again. Period is not 12. Period is 24. I don't like the period so much. What do I like to divide it by? 4. And if you divide the period by 4, you get 6 hours. Every 6 hours, something important happens. You get one of these 5 points. Given that 6 hours, now I really like the 8 and the 20 that I see. Starting at 2, just keep going over by 6 hours at a time, and you'll hit all of our points. Okay, ultimately, we're interested in a sinusoidal function, an equation. This graph is exactly the one that we've drawn. All right, let's see if we can find it. It feels like, let's see, we needed the period. I'll put it back again here. The period was 24. We needed to know the amplitude. Can you guys hold up the number of fingers that is the amplitude? All right, so we can barely do it, right? Almost have to break out the toes to start counting higher, but the amplitude here is 10. It's how far from the middle to the top or the bottom. We've got amplitude, we've got period, we also need the midline. What is the equation of the midline? It's y equals 50. All right, I suppose we didn't need those 2 points, but we did need the 50. We need to know where the middle is. I'm going to leave the phase shift blank for a second. What does it look like the phase shift is? Looks like 2. How far to the right has the graph gone? 2. Anybody think they could name another thing that the graph has been shifted by? Maybe by 14. I mean, if you're saying 2, then you're thinking the graph originally started at the bottom and it just shifted over 2. But if you want the graph to start at the top, then it actually shifted over 14. Couldn't we want the one in the middle? And then really it shifted over 8. How many different equations are there that land on this thing? Infinitely many. We're going to write down 3 of them. Y equals Okay, let's first start with this guy up here at the top. I'm going to think of my cosine function starting at the top. So it's cosine. What number goes in the front? Give me one of those words. Amplitude always goes in the front. So that's a 10. I'll put the t here. Still got some work to do. I'm going to stick on a number at the end here. The number at the end is always the midline. So 50. And there's a tiny bit of work left to do to fill in the blanks. Let's fill in the first blank. First blank, what letter have we been calling it? We've been calling it a B. B is intimately related to which of those words? It's related to the period. Okay, I jumped the gun before. I wrote down these two equations. Finally, we're going to use the second one. We know the period is 2 pi over b. If you just do some multiplying and dividing, you find out that if you want to know b, you just take 2 pi and divide it by the period. Every time you want b. So here, b is 2 pi divided by 24, which is pi over 12. That's the b. That's the thing that goes in front of the t. Okay, and then all we have to do is shift it horizontally. I'm going to draw something that will disappear in a second. Normally cosine starts where? Starts at the top. So I'm thinking of a graph that normally would have started at the top and gone down and then back up. But it wasn't there, it was over there. How do I get to the green? Just shift to the right by 14. This point right here needs to go 14 spaces to the right. How do you make it shift to the right 14? You put in a minus 14. That equation gets you that graph exactly. Yeah, the starting point is in some sense arbitrary. We started with that top point. Let's instead start with, this guy right here. Is that a top, middle, or bottom? That's a middle. Is it on its way up or down? It's on its way up. Here are the four things. Which one of these starts in the middle and goes up? Sign, positive sign. So let's write that guy with a positive sign. In fact, if I had a copy and paste thing here, I would use it to much success because just about everything is the same. Amplitude is the same, the period is the same, so the B is the same. The midline is still 50. But now we're changing our perspective. We're thinking of it being a sine function, starting in the middle. And again, I'll draw something that will go away, but normally sine would start in the middle and go up and down, lost track, up. I don't know what I'm doing. Here, this is why I need my points. There. I'm trying to match them to these points, but those aren't the right points. So I'm just going to draw this. Normally it's that, but this guy needs to get over here. How far to the right did it go? 8, and that will land it on this thing, which doesn't look like a sine because I haven't drawn enough of it, but shift it to the right 8, and we get a minus 8 right there. That graph will land perfectly on, that equation will land perfectly on the graph. Okay, we have like just over a minute left. I'm going to ask you guys to write 2 more equations. Can you write one equation so that this is your quote starting point? That one right over there. Can you write an equation so that that one is your starting point? The 2 things I've circled in purple. Write 2 equations, check with your neighbors. All right, so I have squeezed in and probably not legible anymore my two answers. So starting with that first point, it's at the bottom. If it starts at the bottom, it's a negative cosine. There's no bones about it. So it's a negative cosine. Negative cosine would normally start at the bottom on the y-axis, but shift it to the right too, so there's a -2. And how about the other purple point I circled? Is it a sine, cosine, negative cosine? That's a negative sign. It's in the middle on its way down. So I've made a negative sign, shifted to the right by 20. Okay, we'll see you guys on Wednesday.